Okay, good afternoon. Welcome back. Happy Friday. So we're going to go ahead and start. We're going to do things a little bit differently today because I fully appreciate that last class was chock full of algebra rules, and exponents can be very difficult, especially with all of these rules that are coming at you so fast. So today we're actually going to continue talking about exponents. So we'll have some more rules to give you about exponents. But two pieces of good news. Number one, today's rules are much less intense than the last class. Last class was a whole lot of different things. Today it's really just one main idea and we'll apply it. I don't think it'll be as challenging as last class. And number two, we're going to spend a few minutes right now at the start of class just looking at some of the tough problems from last night's homework. So before we dive into that, I just want to let you know that next week, what's happening on Tuesday? Advising day, right? So no day classes on Tuesday. I talked to you guys last class about all the reasons you should come in and not just call it like a day off from school. So hopefully you'll be coming in. Actually, there are copies of the schedule, paper copies of Tuesday's advising day schedule right across the hallway in the math studio. So you can look at the list of all the workshops and you can discover there's free food at lunch and there are free massages during the day. So please come. If you're thinking about maybe taking an online course for the first time, but you don't really know what it's about, maybe you don't know how much time it would take, you don't know what the process would be, there is a workshop coming up this Monday at noon. So Monday, April the 1st, right before our class, there will be free pizza, but that's not really the main reason to go. The reason to go is so you can learn about taking online classes. I personally have never taken one, but before I would certainly sit in on something like this. Any questions on that? It's in the McLeish room, right outside the library. Okay, so so we're going to start on page 19, but like I said, we'll begin today by looking at just a few homework problems. So I'm going to copy something from the side of the board here. So number 5C is the fourth root of 48a cubed. Do I have that right? Who wrote those over there? Was that Sevtap? Yeah, Teresa? 8 to the 9. Okay. All right, so let's take a look at this one. So you know what? Here's the first thing you need to ask yourself. Square roots behave nicely sometimes, and they behave very poorly other times. So which two of these behave nicely? It's the top two, right? If you have the square root and it's multiplication, you can do something with that. You can split that up into two different radicals. If you have a square root and inside it's a division, you can split that up into two different radicals. If you have square root and it's addition, you can't do anything. Square root with subtraction, there is no rule for dealing with the square root when it's addition or subtraction inside. So really the first question I ask myself, I see 48a to the 9th, I want to know what is it? Is it addition, subtraction, multiplication, or division? It's multiplication. And so I'm going to put in that invisible dot that's there just so I can kind of tie in. I've got a rule for dealing with multiplication, so that's the rule we're going to use here. So what we want to do is think about splitting this up. And I'm going to split it up in such a way that the first part is the good stuff, and the second part is the leftovers. So 48. Is 48 a perfect fourth power? Does it have a nice fourth root? And the answer is no, but even if you don't know, you go to the first page. So just jump to the first page. There's that nice table there. This is a fourth root, so you're looking at the fourth powers. Do you see 48 in the list of fourth powers? No. So 48 is not a nice number to have in there. But maybe there's a number that goes into 48 that is nice. So look in that list of fourth powers and find a smaller number that goes in perfectly. Do you see one? 16. 16 goes in perfectly. So we're going to split that 48 up. Part of the 48 is going to be in the good piece, and the other part is going to be whatever's left over. So 16 goes right out there, and then you actually have to do the division. 16 goes into 48 how many times? 3 times. So 16 is good. We put it in the front. 3 leftovers. Now I'm going to look at a to the 9th. And I'm going to change it for just a second. What kind of a number could be a good number to have up there? Forget about the 9. Just make up any number that would be nice to have up there. 4 is good. 8 is good. think I heard a 12 and a 16. Those are all good numbers to have up there because we know that the basic rule when you have a radical and then something to a power is you do what to this number relative to that number? Is we divide, right? If it was to the 12th, you take 12, you divide it by 4. That was a shortcut that we figured out last class. So the reason all those numbers are nice is that 4 goes into all of them evenly, right? The problem is that the power that we have is not in that list. The problem we have, it has a 9 up there, and 4 doesn't go into 9 evenly. So what we're going to do is we're going to split off. We have 9 A's to play with. You're going to put some of them in the good radical, and then whatever's left over will go in the other. Can you find a number that's in the list that we just erased up here that's smaller than 9? 8 is good. 4 is also good, but you want to pick the biggest number in the list. So I'll put up here the list again. 4, 8, 12, 16. You're just looking for all the multiples of 4. And the one that we're focused on is 8 because it's in the list and it's smaller than what we have so far. So we're going to put 8 of those A's there. You had 9 of them, so how many are left over? Just a single one. And by splitting that radical up in exactly that way, we have a perfect fourth power in the beginning. And again, it's multiplication, so we're just allowed to bring them out one at a time. What's the fourth root of 16? Is 2. You can again go back to the list on the front page there. And then again, what do we do with the powers, the 4 and the 8? Is we divide, and so we get a to the 2, a squared. For the powers, yeah, so then to figure out this power right here, we took the 8th power that we had, and we divide it by this number in the front. We get a squared. And then I'll just copy the leftovers. There's nothing else to do with them, times fourth root of 3a. That's it. Questions on that one? Not saying it's easy, but if you understand the rationale, if you understand the reason for splitting it up, then it becomes easier to remember what the process is. Okay, so that is that one. The next one I see over there is a cube root of 900,000. This is 3b. Okay, and then there's a question written on the whiteboard. When do you decide to stop to simplify? Whose question is that? It's Teresa or Septak? Can you say the question again? What are you asking?
The answer is n, and then q.
Right. Okay, so we're trying to simplify this one right here. All right, so first of all, there's no variables in this one. So we're not splitting it up like over multiplication like we did before. But we are going to split it up because 900,000 is not a perfect cube. I mean, the list doesn't go far enough, but the goal here is to recognize you can take 900,000 and split it into good stuff and whatever's left over, just like we took 48 and split it into good stuff and whatever's left over. So what do you do when you have a number that's so big that it's not reasonable to know what all the factors are just like that? Well, we're going to take this and we're going to write it as 2 radicals. And all we're trying to do is find any perfect cube that goes into 900,000. So look at your list of perfect cubes. There's not many, so the numbers aren't very big. But can you find a number in the list of perfect cubes that goes evenly into 900,000? 1,000 goes in. Does everybody understand what we're looking at with this list? So you just go one at a time down the list of perfect cubes. Does 8 go into this number? I don't know. It might. You can check. Type it onto the calculator, but clearly 1,000 goes into it. And so you want to grab the biggest number you can find. So let's be greedy. The last number in this list is 1,000 and it works. So that means I'm splitting up my 900,000 into 1,000 times 900. Everybody see the division? Right? 900,000 divided by 1,000. We get that. And then the cube root of 1,000, I mean, it's 10. It's on the table. Just look over in the first column of the table. This is 10. and then the cube root of 900. Now 900 is still a big number. And if there's still a perfect cube that goes into it, we have to pull it out. So we're not necessarily done until we can't pull anything else out. So looking at the number 900, and then again coming back and thinking about our perfect power list here, it's our job to look at these perfect cubes and just see if there's anything else that goes into 900. Start at the bottom. I mean, it's a big number, so you want to find the biggest thing you can. Does 1,000 go into 900? No, it's too big. Does 729? No. Does 512 go into 900? Definitely not. 343. It doesn't feel like it should. I mean, it's kind of a messy number at the end. 216. Maybe that one goes in, but you got a calculator, so you just try. You take the 900, you divide it by 216. You type it in, you'll get some decimal. Means it didn't work. Didn't go in evenly. You take 900, you divide it by what's the next one on the list? 125. To me, that feels like that has a lot of potential because 25 goes into 100. So maybe that one goes in. Does this one go in? No, but you try. And it's a pretty quick try. You can just take 900, divide by each number one at a time. You will see that none of these other numbers goes into 900. So we're done. Even though 900 is big, nothing goes into it evenly that's nice. Does that make sense? How would you split the 900? Yeah, you could totally split it up any way you want. You can split it up as 109. And now 9 is not in that perfect cube list, so that doesn't help me. And 100, you can look at all these numbers up here. None of them is divisible by 100. So yes, absolutely, you can split it. But there are other ways to split it too, you know, like 30 and 30. And there might be many ways to split it. So, but I think we have proven that nothing goes in. None of those numbers in a list goes into 900. So we're done. Teresa, does that make sense? What don't you like about that? Go ahead.
So you never need to change the column in the cube or
No, if it's
you're done with that.
that's right. So if it's a cube root problem to start with, the only thing you're looking at is that cubes list, and it will never change from a cube root. Yeah. Yeah, then it would be quite challenging because like 100 goes into 900, but 100 is not in the right list. It's only cube roots for this problem. Yeah. Other questions or comments about this one? Okay. So let's take a look at the next one on the board. Okay, so what's, is there another one over there? The cube root there? Okay, let's do that one. Okay, this is number, I don't know what number it is. It's the cube root of negative 40 over 27, 3c. Okay, if you give me a fraction, the first thing I always do is see if it's reduced. Because if I can divide both of those numbers by something and make them all smaller, I will do that always first. Is there anything that goes into 27 and 40? Nothing goes in. I mean, 27, the only numbers that go in are 3s. Okay? 3 times 9 and 3 times 3 times 3. And 40 is not divisible by 3. But it's worth a look. So if it doesn't work, then I'm ready to apply my rule that says I can handle these guys separately. Division is nice. So I'm splitting it up so I don't have to worry about it. It's not a fraction anymore. People get scared when they see fractions. Okay, so don't make it so it's not a fraction. Just deal with them separately. Okay, the bottom is actually a nice number. The cube root of 27 you can find. It's in your list. What is it? It's 3. So that one's done. But the 40, all right, so forget the negative, but is 40 in the list? No. So then I'm feeling like we're probably going to split it up just like we did before. Good stuff, and then whatever's left over. So find a number in the cubes list that goes into 40. 8 goes into 40. So you write 8, and then whatever's left over. How many times does 8 go into 40? 5. I lost something. What did I lose? Lost a negative. It makes no difference where you put it. I'm going to put it over here with the nice thing because the cube root of 8 is nice, and so is the cube root of negative 8. But it really doesn't matter where you put it. So Let's write our answer. I'm copying the 3. I'm copying the cube root of 5. Only thing left is this guy in the front. Yeah, forget the negative, but what's the cube root of 8? It's 2. What's the cube root of negative 8? It's negative 2. It's negative 2. It's the only thing that has a chance of working. If you want to check to see that it really works, multiply negative 2 by itself 3 times. What do you get? You get negative 8. Right? First 2 negatives make a positive 4, but then the final answer becomes negative 8. So it's just plain negative 2 in the front. Questions on that one? Is that time? That's right. Yeah, so if you don't put the negative in the front and you put it in there, it's also the same thing. Both the same. Mm-hmm. Mm. So the question is the answer in the book, which is right here, is it the same as the answer that we got? So the first answer that we got. Yes, it is absolutely okay to leave it the way that we had here. The book has decided they want the radical to be by itself. That's fine. What is this divided by, even though it's invisible? Divided by 1. And if you put that in there and you multiply back through, you'll see it's exactly what we had. So the book might just decide they're always going to put the radical separate, and that's okay. And so is what we did. Any other questions on that one? Okay, the last one I see is on this other board here. It's the square root of 16 minus 4x squared. And this one, I got to say, looks like we can't do anything. It looks like we're stuck before we even start. Because what's that? 7c, thank you. What's the operation in the middle of this one? Subtraction. And up here at the top, we decided radicals work really well with what? Multiplication and division. Radicals do nothing at all with addition and subtraction. So it feels like we're looking at this last case right here. There's a radical with a subtraction, and you can do nothing with that most of the time. We're going to turn this thing, which we can't do anything with, into this thing, which we can. We're going to turn it into a multiplication problem. We're going to have a lot of experience with this later on in the semester, so this is a good time to maybe just see it for the first time. What can you factor? It's the first time I'm using that word in this class. What can you factor out of both 16 and 4x squared? You can factor out of 4. People know this word? How much comfort do you have with the word factor? So what we're looking for is something that goes into 16 and into 4x squared. And 4 goes into both. So what we're going to do is we're going to factor that 4 out, and then we're going to write down what's left. 4 times whatever this thing is supposed to be 16. What must go in there? That must be a 4 minus. 4 times whatever this is, it better give me 4x squared. It's an x squared. And if you're not sure whether or not that's right, all you need to do is distribute. And you're going to see that you get exactly what we started with. So factoring is like the opposite of distributing, kind of undoing. Somebody distributed, let's undo. Let's go back to where we were before. Okay, now I see 2 operations. I see a multiplication and I see a subtraction. What's the primary one? It's a multiplication right now. Like this thing here in the parentheses, I don't really know what it's just one thing, right? So like if it was just a y, then it would be 4 times y, and there wouldn't be even any subtraction at all. So this is really a multiplication problem. And since it's a multiplication problem, we can split it up into 2 radicals. What's the first radical? 4. What's the second radical? 4 minus x squared. Okay, the first square root is nice. What's the square root of 4? It's 2. second square root. What's the operation? Subtraction. In between it's multiplication, but inside the square root is subtraction. Can we do anything with subtraction? No. I mean, we had to work really hard before to turn the subtraction into multiplication. And we can't do any more. 4 minus x squared, you just leave it. No matter how tempting it is to say, oh, it's just 2 minus x. It's not. So that's the answer. So feel free to update like any of these on your homework and fix it if it's not right. Any questions on that? Okay, so I hope that was helpful. Again, I acknowledge that last class had a lot of stuff in it, and exponents can be very tricky, and all these rules can kind of add up and make it so it seems like the homework is impossible. So I hope that this was useful. I wish that we had time to do this, like the first 15, 20 minutes of every class. We don't have the time to do that, which is why, you know, we talk after class or during office hours, or you meet peer tutoring or the studio or anything like that. But I wanted to slow down today. Okay, so we begin on the next page, which is here, 19. So open to page 19. We talked about the calendar already, right? Did we talk about the calendar? No, we didn't. Okay, so we are here. Today we're going to be introduced to rational exponents. Rational is just a fancy word for fraction. So the exponents today we will see will be fractions. And then the next class, it says we're going to work more with radicals and products of, I think that says binomial things. Then we're going to see this important word factoring. We used the word factor today, so I think that was great. And then more about factoring, and that's going to be a really important technique for us. And then finally, it's a little ways away, but our third quest, April 8th. What day is that? That's a Monday. So a week from this Monday is our third quest, and it's going to be on classes 19 to 23. I will highlight those while it's here. This is what the quest will be on. So I just want to point out a couple of things. Sometimes we have like a review day before the day before a quest. We don't have that for this quest, but I also want to say that the 2 days right before the quest is not on the quest. So, you know, like there'll be time hopefully to study this stuff, not worry about, you know, if you're a little bit behind in that factoring stuff. It's not going to be on the quest like the very next class. Melanie? 24 to 30. Yeah. Okay. All right, so that's what's coming up, and let's jump in here. One more announcement. I've written it here on the board. I don't have my office hours right after class today. I am available for like 5 to 10 minutes right after class, so we can take questions right then, but then I have a meeting in the other building at 2:30. I apologize. The good news for you, but probably more for me, this is the very last meeting of this committee ever, so I won't have to cancel any more of these things right after class. So I apologize for that. What's that? It's good news for me. It's one less meeting I'll have to go to all the time. What's that? Oh, I do enjoy it, but it's a lot of meetings. Okay, so here we are on page 19. It says today we'll examine the relationship between radicals and exponential notation. Number 2, can we start up here with Dan?
We also noticed that if the radical of multiple then we multiply the radical by
Okay, so there's a lot of vocabulary in there, and frankly, we actually skipped some of it last class. So let's slow down and make sure we're good with the vocabulary. First of all, what do you do with the powers when you see something like that? We divide those powers, right? Divide the powers. So the radical has a lot of vocabulary associated with it. So the index of this radical is that number. I'm defining the word index, and it's the math word for the number that's right in front of the radical, okay? So that index is 3. How about for like a fifth root? What's the index? It's 5. For a square root, what's the index? 2. Okay, so the index is just the name of that number in the front. And then the other vocabulary word here is radicand. Where is it? Here it is. The radicand is the entire thing inside the radical. Okay? Radicand is the thing inside. Okay. So here's something we saw last class, and it's true even if the exponent isn't a multiple of the index. It says the nth root of x to the k. Again, what do we do with the powers? We divide them. And in fact, we had this property written, that formula was written exactly like it is here on the last few pages. So we've seen that before. It just says you're supposed to divide them. So for example, this one is really equal to x to the 6 divided by 3. Yes? X to the 2. Okay, and it's a little bit more common to write that rule this way here. So we're going to write it as x to the, and then we'll make it a fraction instead of writing the division symbol over here. So x to the k over n. And then it says put lots of stars around that formula. So go ahead and put stars. That's the most important thing for today. I feel like I have a star thing somewhere. I don't know where it is. Symbols. Where do you see symbols? There's a shapes. That thing. It's a fill. Creative pen. Magic. Oh, there's crayons. Okay. So stars around that formula, it's the important one for today. So our next example here says the fifth root of x to the 8th is just 8 to the, and what do you do? Sorry, x to the. What do you do to the powers? Divide them, right? 8 divided by 5. 8 divided by 5, and that's it. Now last class, we would have said x to the 8th is no good. We need to split it up into some good stuff, and then whatever's left over. Today we're going to say, hey, it's okay if it doesn't go in evenly. We're just going to write it as a fraction up there, and that's fine. So here's the deal. If we all believe that the fifth root of x to the 8th is okay to write as x to the 8/5, then right there, we have given meaning to x to a fraction. If you see x to the 8/5, what does it mean? Oh, it means somebody took the fifth root of x to the 8th. So the problems that we have are mostly going to be going the other direction. I'm going to give you x to this fraction. What does it mean? It means x to the fifth root of x to the 8th. So let's see. How are we supposed to know? Let's do an example right here. X to the 2/3. Can you guys write that? I'll start you off. It has a radical. X to the 2/3. Where did it come from? So where does the 2 go? It should be x squared, right? And then cube root of that. Everybody see it? Yeah, so really like the only, so there's only really one way to get this wrong, and that's to accidentally swap where you put those two things. So 2/3 apparently goes 2 there and 3 there, but it's so easy to put them in the wrong spot. So again, came up with some silly stuff here. Don't forget, index is which number? It's the one in the front, and apparently it's the one from the bottom. So the index, I don't know if it's like a ship thing, goes below deck, right? Like downstairs. So the index goes below deck. The index is that one. It goes below deck. It's in the denominator, okay? And then the other one, the power, when we say the power, we mean this one, right? That's x squared. That's the power. It grows up like a flower. I made those up. All right, so let's see if we can rewrite in exponential form. Go ahead and do parts A and B. All right, so for part A, what's the right fraction power? 9/7 or 7/9? 7/9. Everybody see where the pieces go? For the second one, Katrina asked a good question. Do we keep it in parentheses? Absolutely. It's the whole thing, and then we've got our property. What's the power? 13/11. All right. You get no information. I know some people would say, oh, okay, I just have to put the smaller one on top and the bigger one on the bottom. Is that true? No, depends. There's no way to know based on which one is bigger or smaller. It's really a matter of where the pieces are. Number 5 says we can also go in the other direction. So I'm going to give you the fraction power and ask you to write it as a radical. Go ahead and try parts A and B for number 5. Okay, let's try part A. I've got a radical. Is it a square root or a 7th root? 7th root. X to the 2nd. That's good. And then over here, again, keep it in parentheses. We've got radical 5z in parentheses. Where does the 17 go? It's inside. It's up there as the power. 18 outside. So if you feel like inside and outside are more memorable to you than what I said, then try to come up with some way to just connect. One of them goes inside, one of them goes outside. You just got to get it in the right order. All right. Okay, number 6, let's try these together. We're going to evaluate all of these things right here. We'll start with 9 to the 1/2. So first, don't do what I do or what I did. The first time I saw exponents, I forget what grade I was in, but I took this entire quiz and I said, oh, exponent just means you multiply the numbers. So when they said 3 squared, I said, oh, 3 times 2 is 6. Only quiz I've ever gotten a 0 on. So this one right here is not 9 times 1/2, it's 9 to the 1/2. So let's first translate this into a radical. 9 is in here. Where does the 1 go? It goes inside, it's up there as a power. The 2 is outside, it's there. So this is really just finding the square root of 9. What is the square root of 9? It's 3. That's the answer. And I just want to point out that even if 9 to the 1/2 is completely foreign until just a moment ago for some of you, that the calculator knows what it is. 9, and then there's a power button here, and then I'm going to put the 1/2 in parentheses just so that it's clear there. So 9 to the 1/2, I'm going to hit equals. What's it going to say? It's going to say 3. All it did is the power right there. Equals 3. Which also means actually if I do 9 to the, what's another way to say 1/2? 0.5? Yes? But the answer had better be what? Better be 3. Whether you write 1/2 as 0.5 or as a fraction, still 3, right? So the calculator knows it. Okay, let's try this next part right here. Again, same idea. Write it as a radical. Katrina's suggestion still in play. Keep the parentheses. Where does the 2 go? That's out in the front. You don't have to write it because it's a 2. I'm going to write it every time. So this problem is really saying find the square root of -9. What do we think about that? Square root of -9 does not exist for us at this moment in this class. Square root of a negative number, yeah, you'll be introduced to imaginary numbers later on, but right now it's just not a real number. Yeah, Melanie. Yeah, so that's why it doesn't work. That's the natural thing to try, but it doesn't work. So we just say not real. Square root of any negative. That's the end of the ball game for right now. Okay, let's try this one. So I see a square root. I'm going to put a 9. But the question is, where's that negative? Because if the negative's inside, it might be different than if the negative's outside. It's outside. That 1/2 power is touching what? Just the 9. And that negative, I'm going to write it here, that negative really means -1 times. Right? That's what a negative sign means. It means -1 times. And we know that order of operations, PEMDAS, exponents come before multiplication. So that negative is just sitting there in the front. I'll put it right there. And now I'll deal with the half. Where does the 1 go? On the 9, the 2, outside. So this is saying find the square root of 9 and then do what to it? Make it negative. Multiply by -1. So we get -3. Just highlighting. The answer to that one and the answer to that one completely different. So you really got to be clear where that negative is. Okay, part D. Again, take a moment to write it as a radical. So put the 1 somewhere and put the 3 in the other place. So this problem is really just the cube root of 27, which is 3. Done. For this next one, is that negative inside or outside? Inside. It's in the parentheses. This is a cube root. Last problem we had a not real answer. Cube root of negative 27. This actually is a real number. It's negative 3. What is this equal to? Negative 27, which is exactly what I wanted. I wanted a number times itself 3 times to give me negative 27. It worked. But how come it doesn't work for when I wanted to get the square root of negative 9? Negative 3 times itself is how much? Positive 9. Can you multiply two numbers, the same number by itself, and get a negative? No, there's no way, right? It'll become positive. So I think I heard somebody say even and odd. That's exactly what distinguishes the not real ones from the perfectly real ones. Right? Yep. So if I asked you for the 4th root of negative 64, you say, that's real funny. That's a good one. 4th root, no good. 5th root of negative 64, it's a wonderful real number. Right? So evens and odds, very different. Okay, this next one, part F. Where does the negative go? Inside or outside? That negative has nothing to do with the power, so it's just sitting there waiting for you to deal with the radical. So this is negative cube root 27 to the 1st. Good. So the cube root of 27 is just 3. Negative sign was waiting there until you were done. Any questions on those? Okay, let's take a look at number 7. I'm going to do this one in 2 different ways. 8 to the 2/3. 2 different ways. So the first way is the only way we have at the moment. So this is a radical. There's an 8. Where does the 3 go? 3 is cube root outside. 8 squared. Okay, so let's find this. So first you better do 8 squared. 64. And then the cube root of 64, maybe you know it, maybe not, it's on the list. That one's 4. So we're going to try this in a different way. I'm going to do this one here. So we all agree that the 3 goes where? 3 goes outside. And then the 2 is supposed to be the power, right? I'm going to write it in a different way, and it shouldn't at all be clear that we're going to get the same answer. I'm going to put the power not on the 8, but on the whole thing, just to see what happens. So what do you do first on this one? Do you square it first like we did in the red, or do we cube root it first? We cube root first. Okay, the cube root of 8 is easy. I mean, it's on the table, but I'm hoping you know the cube root of 8. It's 2. And then what do we still need to write? Is the squared. And 2 squared is 4. Right. So this is some freedom that you're just now discovering, is that you can either do that power inside first, like in red, 8 squared, you do it first, or you can do the power last. Which one of these was easier? To me, it feels like the second one. That's just a personal preference. Yeah, the second one never gets something as big as 64. When we got to the cube root of 64, many of you had to look in your table. But the cube root of 8, it's easier. Didn't have to look in the table. And it makes the number small before it gets big, as opposed to big and then small. So you can do it either way. I encourage you every time to do it the second way. Tenzin. On the quests and the tests, you can use calculators, not the graphing one, but you can use one with the power button. It can do too much. Next semester, you can use a graphing calculator. Okay. All right. Let's go to the next one. Number 9. Shh. Okay, most important fact for today. If you see the nth root of x to the k, where does the n go? Upstairs or downstairs? Downstairs. That n was down there, the k was up there. And then what we've just decided is that you could actually, instead of doing the power in here, you could decide you're going to do it out there. You do need parentheses there. Good point. Okay. So let's try these next two, and hopefully I can convince you that the second way is better. So we're writing a radical. I'm writing negative 32 in parentheses. The number in the front is definitely 5. The power is definitely 2. Now you have a choice. I'm going to write this 2 in a different color. You can either put the 2 here, or you can put the 2 out there. And I'm telling you, one of them is easy, and one of them is going to require a lot more calculation. Anybody happen to know what 32 squared is? Yep. 32 squared. 32 times 32. It is 1,024. Young Ben just typed it into his calculator. But it is 1,024. But nobody knew that without the help of the calculator, right? So perhaps we'll try the other way. The fifth root of negative 32 is 2, negative 2, right? The even odd thing here, so we're okay with the negative inside of here because it's odd. So this is equal to negative 2, and it is still what? Squared. And negative 2 squared, positive or negative? Positive, even. Okay. So it is the same, and if you have the calculator, it's really, you know, half a dozen of one, 6 of the other. I mean, it's the same. But if you don't have the calculator, if you just want to try to do stuff in your head, definitely squaring it first is a bad idea, because that gets to 32 squared, which very few of us know. 81 to the 3/4. Same game. Write the radical, write the 81. What's the number in the front? 4. The 3 is the power. You have 2 choices. If you put it inside, you're going to have to do 81 cubed. If you put it outside, you don't have to do that. So put it outside. 4th root of 81, it's on the list. You might know it, but it's on the list. It's 3. So this is really 3 cubed, which is 27. All right, we're moving on to 11. Can we go to Teresa for 11? Okay, let's try 11A and B right here. Okay, very frightening exponent. It's negative and it's a fraction, but we're just going to deal with them one at a time. My suggestion is you deal with the negative first. If you see a negative, remember movement. If you see a negative, you flip it. You move it to where it's not. 16 becomes, that's not the kind of flipping we do. Means you flip over, it becomes 1 over 6. Yeah, this is 16 over 1. You flip it, it becomes 1 over 16. 1 over 16. And when you move it, what happens to the power? It was negative 3/4. What is it now? positive. It doesn't, you don't flip that power. We never flip the power. We're only flipping the thing that the power is touching. Yeah, so if we have 3 to a negative 2, what that means is 1 over 3 to the positive 2. You never flip the 2. You just change it from negative to positive. Negative exponent just means move. Okay, 1 over 16 to the 3/4. Well, now you have this whole different problem, but at least it's a positive exponent. So deal with 16 to the 3/4, doing the whole thing with the radical, and then whatever you get, put a 1 on top of it, and we're done. What number goes in front? Definitely 4. The power is supposed to be 3. Did you put that power inside or outside? Yeah. So let's put that 3 out there. Otherwise, we need to do 16 cubed. Actually, 16 cubed, I think I know. 4,096? Somebody do that. 16 cubed? 4,096? Woo! Okay. 1 divided by. What's the 4th root of 16? 2. And then it's still getting cubed. 1/8 is the answer. How did we get 64? Did you get 64?
I got 4 when I did. I just did it
Oh,
wrong.
yeah, right. Okay, part B. Part B, very scary indeed. You see a negative exponent. I said it means move. So what do you think with the 1 over 36?
36.
You flip it, you become 36 over 1. It's kind of a different rule, actually. It's valid, and I think we should use it. I said negative, you move. If it's upstairs, move it downstairs. Downstairs, move it upstairs. Basically the same thing. Fraction gets flipped over. So this becomes 36 over 1. You don't need the 1. To what power? 3/2. Yeah, positive. All you do, change that negative to a positive. Now we have something we can handle. 36 cubed is quite difficult for me. Let me process. So work on this one with the 3/2. It doesn't. Yeah, I can give you an estimate. I'm not going to be able to get to the exact answer. Let's say something around maybe 5,000. Wait, you said it was a 5-digit number. Is it around 50,000?
46,000.
Wow.
That far. You missed the moon and you smashed into an asteroid. Somehow.
I feel like NASA has access to calculators. Maybe it's just me. I feel like they.
I think so. Maybe.
In this case, it is easier. 36 squared.
Yeah, it's always easier to do it in that order. I got 216. Is that right? Any questions on those? Okay, so I'm going to come around and take a look at questions folks had. What you are going to do, you have 19 minutes. There's a group activity here. Answers follow. Check with each other. And then part of your homework tonight is right there on the next page. So start the group activity, and I think you might have some time left over to start on homework. So let's see how far we can get.